All right, welcome back. We're going to start section 4.4 today. Before we get started, though, I know I don't do a lot of warm-ups in these videos for the simple fact that usually it's showing me that you understand, and we're going to handle those in class. So, but for today, I do want to keep a warm-up in here for the simple fact that I want to talk about the multiplicative identity of 4. This is a question that I would have asked you like in chapter 1 when we talked about those properties of real numbers. And a lot of you on your test would put 4 times 1 is equal to 4, where that 1 is the identity. So what the identity is, especially the multiplicative identity, it is what you multiply some number by to get the same thing. So I could have picked any number, and that identity would have been the same. So 4 times 1 is 4. You guys know that. So that 1 is the identity. It doesn't change anything. Today, what we're going to talk about is the identity and inverse matrices. So on the left here, I've got the 2 by 2 identity matrix, and on the right, I've got a 3 by 3. There is a couple features that holds true. You guys really could expand these to 4 by 4s, 5 by 5s, but since we've just been working with 2 by 2s and 3 by 3s, that's where we're going to stay. But these are going to hold for any size square matrix. So the first thing you're going to notice is that we have 1s. Make that look a little more like a 1. 1s on what's called the main diagonal. So that main diagonal is from top left to bottom right, where we always start with our determinant, or our multiplication when we find that determinant. So 1's on the main diagonal, you've got 0s everywhere else. So, nice thing about these is you don't actually have to go through the whole matrix multiplication if you recognize that this is what you're working with. So, just a quick example here. If I have some matrix, I'm just going to make up some numbers. 1, 2, 3, and 4. I know I got original on those. And I multiply that by that identity matrix. 1, 0, 0, 1. I could go through the entire multiplication process where I move the 1 and the 0 over, multiply and add, move the 0 and the 1 over, multiply and add, and I make my 2 by 2 matrix. Or I could realize that since this is the identity, you're going to get the exact same thing out. So real quick, I already know that my answer is going to be 1, 2, 3, and 4. Right like that. So that's the identity. You're going to get the same thing when you multiply by it. So the more interesting thing that we're going to talk about today is the inverse matrix. So if you multiply something by the inverse matrix, you are going to get the identity matrix. So, remember these guys we were just talking about? You multiply something by its inverse, and I'll show you how to find those in a little bit here. But if you multiply something by its inverse, you're going to get the identity. So, 1's on the main diagonal, 0's everywhere else. So, just to illustrate that here, I've got A times B. So 3, negative 1, negative 5, and 2 multiplied by 2, 1, 5, and 3. This right here, if I'm going to call this A, this is going to be A inverse, or the inverse of A. So we show that by putting a to the -1. It is not to the -1 power. It is simply how you symbolize that that is the inverse. You multiply those two together, and hey, you get that 1, 0, 0, 1. One's on that main diagonal, and that's your identity. So this second matrix here that they're calling B, that is going to be your inverse. So multiply by the inverse, you get the identity. Cool little fact. So how do you find these? If I have some matrix, A, B, C, D, first thing you need to do is you need to find the determinant. So hopefully you guys haven't forgot about those, but absolute value bars around A, since we're dealing with a matrix, this is our determinant. So you have 1 divided by the determinant. A lot of the times these end up being 1. Where I catch you is when I make them not 1. So be aware that that's something that I can do to see if you really understand what you're doing. Then all you do is you're going to switch your numbers on your main diagonal. Your A and D have flipped places. So you're going to switch your main diagonal. And then the only difference between B and C in these two matrices is they've just changed their signs. So it doesn't mean that B is always going to be a negative. If I put a negative number in there, it becomes a positive. Change signs. On B and C. So the next part of this takes you through what the determinant would be, A times D minus C times B. We've calculated those enough. And then if you need to, you can multiply through by whatever that scalar becomes, whether it's 1/2 or whatever. So looks kind of confusing, kind of out in the middle of nowhere. So let's take a look at an example here. If we're going to find the inverse of A, first thing, always find the determinant of A. Especially with 2x2s, these go pretty quick. Multiply your 3 by 2 minus 4 times 1. So you're going to end up with 6 minus 4 or 2. Okay? Keep that in mind. We're going to need that here in a second. So to find the inverse of A, we have to take 1 divided by the determinant, which is 2. And then we switch our main diagonal. Our 3 and our 2 have to switch places, 2 and 3. And I change signs on my 1 and my 4. In this case, since they were both positive, they both go to negative. And now all we do, multiply through by that scalar. Remember, when we multiply by the scalar, it's almost like a distributive property. Everything gets multiplied by this 1/2 here. It's going there. It's going there, there, and there. You end up with your final matrix. 1, -2, -1/2, 3/2. And that's all there is to finding a matrix. So finding the inverse of a 2x2. So again, don't forget to find that determinant of A. I know it's easy to forget. Most people remember to flip your main diagonal and change your signs, but it's that determinant that really trips people up. So hopefully this makes sense to you. If you guys have questions, let me know. We'll get them sorted around, and we'll practice this more in class, and I'll see you guys then.